Good evening. Welcome to this Made Easy GTQ session. Myself, I am Srinivas. For this computer science students in GATE 2025, the coming exam, what are the most expected questions? What are the most probable questions from the subject of the digital logic? I will be discussing here now. You are having, I think, almost 20 days time you are having now for your GATE exam. You are having GATE exam on 1st February 2025. You are having exactly probably 20 days time. Hopefully your preparation is going well. So, without any difficulty, probably you will be scoring well, everybody. We hope. In this subject, as I said, most probable question, most expected questions of GATE 2025, I will be discussing. I will be covering here few of the very good questions. Few of the very good questions I will be covering. Your preparation is up to the mark. Most probably you will be answering to the questions. What are the questions I am going to discuss now? Before giving my solution to any question, I will be expecting answer from you. Before giving solution to any question, what I am going to discuss in this GTQ session, I will be expecting answer from you. I want to see answer from you. So try to respond with your answers. Try to respond with your answers. Let me start with a simple question of this number system. Here I said A and B are two 5-bit registers, contains the data. We are having the register A data is 0, 1, 0, 1, 1. The register A data we are having as this 0, 1, 0, 1, 1. And the register data, the data of the register B is 1, 0, 1, 0, 1. Which of the following results are correct? This question I given as MSQ question. So while looking to the options, you try to pick your answer. While looking to the options A, B, C, D, what you are looking on the board, try to give your answers. I want to see answers from you. So try to give your answers. Try to respond with your answers. If you try well, you are having answer for this question as this A and D. You are having answers for this question as A and D. If you try well, these are the answers what we are having. So option A, what is mentioned option में क्या बताया? A plus B equal to 6 base of 8 if A and B data in sign magnitude form. If the content of register B is in sign magnitude, if we are having this data in sign magnitude, we are looking A, we are having sign bit is 0, so positive number. And the remaining bits, if you look 1011, they are referring to the magnitude part. So 1011 is giving 11. So the number is 11. And if you look to the register B, we are having the sign bit is 1. So whenever the sign bit is 1, the number is negative. And for this number, whenever we are reading the magnitude, we are performing 2's complement form. Sorry, it is sign magnitude. So we are performing direct conversion of this magnitude. So the magnitude, if at all we look, the magnitude we are having as 5. So we are having the register B data is minus 5. It is giving plus 6. So that option A is correct. In the option C, it is mentioned A plus B equal to 0 if A and B are in sign magnitude. In option A and option B, sign magnitude is mentioned. So based on this, definitely option C to galat hai. And coming to the option B and option D, it is mentioned the data is in 2's complement form. So if the data is the 2's complement form, A is positive number. Agar A positive number, then it is simply as equivalent to as sign magnitude plus 11. And coming to this B we are having as negative number. So B is negative number. The negative number we are having it is 10101. So number is negative. We are performing 2's complement operation on this total content. When we are performing the 2's complement operation on this total content, we are looking here, it is 1101. So it is 1, first bit itself 1, later bitwise complement we are having. So we are looking here, it is, wait. So first bit is 1, next bit onwards bitwise complement. So 1, next it is 0, next it is 1, it is 0. So if you are looking here, when the data is in a 2's complement form, B is resulting as minus 11. When we are having A plus B operation in the option, option B, option D may be A plus B operation bataya. So whenever we are having A plus B operation, it is 0. So in the option D, we are having the matching answer. The matching answer we are having here 0. Whereas here it is mentioned as 2 with the radix score. Of course, it is not possible. Hence, we are having for this question, we are looking to the right answer is option A and option D. For this MSQ question, we are having the right answers as A and D. Here we are having 5-bit registers. A and B data is mentioned. A and B data for 2 options is mentioned as in sign magnitude. For 2 options, it is mentioned as 2's complement. So while looking to this sign magnitude and sign 2's complement, we are working, which are coming to be the correct options. So while trying, we are having the answers as this option A and option D. Okay. So let's go to the next question. Next question also I took from the number system. We are having one number is 24 with a radix of 8, other number is 24 with a radix of 6. When the number 24 with a radix of 6 is subtracted from the number of 24 with a radix of 8, what is the result we are having here? That result we are reading with the base of 3. What is the x value? It is a question. What is the x value? It is a question. So try. What is x value? It is a question. If we try, the answer we must read for this question as 1 1. Next, I want to see how many of you given right. Very good. Pratik given right. Shiv given right. Chakrabarti given right. Very good, very good, very good. So if you look here, this number 24 is the base of 8. Right? This number 24 is the base of 6. We want to subtract this number from this number which is the base of 8. This number, the base of 6, is to be subtracted from the number, the base of 8. So when we are having a subtraction, better to read both these numbers with the same radix. So better to convert both these numbers in the decimal form, to the decimal form. If you are converting this number to the decimal form, we know it is decimal 20. Because we know here we are having 8 to the power of we are having here 8 to the power of 1, this is 8 to the power of 0. So based on this, you can see this is decimal 10. Right? And coming to this, we are having here, we are having this number is decimal 16. Because here we are looking, it is 6 to the power of 1, 6 to the power of 0. So, while subtracting this number 16 from this number 20, both are in the decimal form, it is a decimal 4. A simple question is given here. So, for a decimal 4, we want to read radix 3 equivalent. Radix 3 equivalent. So, radix 3 equivalent, how to convert, it is a familiar thing for all of you. So if you are dividing this, remainder is 1, coefficient is 1, so 1 1. Hence we are having answer to this question is 1 1. The answer we are looking for this question is 1 1. So we are looking here a simple number system question. It is in need to convert this radix 8 number as well as the radix 6 number to the decimal form. After reading the result, read करने के बाद, what the result we are having, it is to be converted to the radix 3, so that it is checking the knowledge, student knowledge. Exam paper में, if this question is coming, it is checking the knowledge of the student, converting a radix r number to decimal form and converting the decimal number to radix 3 number. So radix converting decimal number to radix r, converting radix r number to decimal, both the concepts are covered with a single question. So what are the questions we are going to look now? Majority of the questions will be having coverage like this. These are the most expected questions. So most of the times we will be having questions in the gate paper which needs the concept of more than one topic sometimes. Let us go to now let us look now a question which is related with the waveforms, which is basically related with the Boolean algebra work. Let us look to the question here which is related with the waveforms. We are having here a question. Consider the circuit shown in figure below. So this is circuit. A circuit में we are having one NOT gate, one AND gate, one exclusive OR gate. In the question it is mentioned, आप question में देखें तो question में it is mentioned as we are having delay of NOT gate is 10 nanoseconds. A NOT gate जो है उसका delay 10 nanoseconds and AND gate का delay है 20 nanoseconds. AND gate का delay है 20 nanoseconds, right? And we are having exclusive OR gate here, उसका delay है 10 nanoseconds, all in nanoseconds. Input A, this is the input A. This input is changing to logic 1. This input is changing to logic 1 at t equal to 0. At t equal to 0, at t equal to 0, input is changing basically. Logic 0 means it is changing from logic 0 to logic 1. A है meaning. Then waveform for the output while. A overall circuit waveform क्या है from the given options. ये है अपने पास question. From the given option से आपका output waveform क्या है? It is the question we are having. So can you try? I want to see correct answers from you. So I want to look answers from you. What is the answer for this? What is the answer for this? If you try well, अगर आप बराबर ट्राई किए तो if you try well, आंसर एक क्वेश्चन का आपको आंसर मिलेगा ऑप्शन बी. If you try well, एक क्वेश्चन का आंसर आपको मिलेगा ऑप्शन बी. I want to see answers from you. So to identify the answer, what we need to develop the overall circuit waveform. We need to develop this exclusive OR gate output waveform. Exclusive OR gate output is depending upon the input A. It is externally given, and the output of this AND gate and the output of this AND gate. So while knowing the output of the AND gate, knowing the given A, it is possible for us to develop the waveform for the XOR output. It is possible for us to develop the waveform for output Y. So that we need to try AND gate output. Later only we can identify, we can draw the waveform for the XOR output. To draw the AND gate output, we need to know this NOT gate output, because AND gate is having one input directly, this A, and AND gate का दूसरा input है NOT gate output. NOT gate output waveform मालूम होने के बाद AND gate output waveform दे सकते हैं. AND gate output waveform होने के बाद we can try for the output of XOR. Hence we need to try first this NOT gate output. पहला अपन NOT gate output try कर लेना. So if you look here, the waveform A, let us take the time slices as 10 nanoseconds, so that 10, 20, 10, 20, 30, 40, 50, 60, I think they are enough. 30, 40, 50 and 60. Right. So A is concerned, it is given. A is given, it is changing to 1 at t equal to 0. It is changing to 1 at t equal to 0. Now, output of this NOT gate for this input, output of the NOT gate for this input, we need to check. We need to draw basically. So 10, 20, 30, 40, 50, 60. NOT gate output we are trying to draw. So NOT gate before T0, NOT gate का input क्या है? Before T0, NOT gate is having the input as 0. So while having input is 0, the NOT gate output is 1 before T0, right? Before T equal to 0, before T equal to 0, NOT gate output is 1. At T equal to 0, the NOT gate input is changing 0 to 1. Whenever the input of the NOT gate is changing 0 to 1, the NOT gate is not responding instantaneously. NOT gate immediately respond nahi de raha. It is having inherent delay. It is having a delay of 10 nanoseconds. So whatever the input it is getting, uska response NOT gate se milega aapko uska response milega only after 10 nanoseconds. Only after 10 nanoseconds uska response milega. So whenever input is changing 0 to 1, NOT gate output 0 होना चाहिए, but 0 होने के लिए it is taking 10 nanoseconds time. It is taking 10 nanoseconds time. 10 nanoseconds के बाद में NOT gate output will be 0. So that it is same one until to 10 nanoseconds बाद में it is changing to 0. So it is the NOT gate output waveform. After changing this A 0 to 1 at t equal to 0, बाद में तो input ये change नहीं हो रहा, so that NOT gate output भी change नहीं होते. So this is the NOT gate output. Now if you come to the AND gate inputs are this A and NOT gate output. These are the inputs to the AND gate. These are the inputs to the AND gate. Based on the truth table of AND gate, now we are working for the output of AND gate. And AND gate also not responding immediately. AND gate is responding after applying the inputs only after 20 nanoseconds. AND gate का response आपको मिलेगा whenever inputs are changing, उसका response मिलेगा after 20 nanoseconds. After 20 nanoseconds. So having this idea, we are working here. So we are looking here before t equal to 0, one input is 0, other input is 1. One input is 0, other input is 1 before t equal to 0. So that before t equal to 0, it is 1. AND gate output we are talking here, output of the AND gate is 1. At t equal to 0, both the inputs are 1. At t equal to 0, both the inputs are 1. It means AND gate output must be 1. AND gate output must be 1. मगर AND गेट आउटपुट 1 होने के लिए कितना टाइम लगेगा? AND गेट आउटपुट 1 होने के लिए 20 नैनो सेकंड्स का टाइम जरूरत है. So only after 20 nanoseconds we are having, sorry, so one input is 0, other input is 1, means before t equal to 0 it is having 0, it is having 0, sorry, it is having 0. At t equal to 0 both the inputs are 1, at t equal to 0 both the inputs are 1. Whenever both the inputs are 1, AND gate output will be 1, but AND gate output will be 1 only after 20 nanoseconds, right? Whenever both are 1, उसका response AND gate से मिलेगा after 20 nanoseconds. So that after 20 nanoseconds from 0, after 20 nanoseconds from 0 means here we are having AND gate output is coming as 1. AND gate output is coming as 1. Okay. Now, if you look to the inputs of this AND gate, at t equal to 10 nanosecond, one of the input the AND gate is changing to 0. One of the input the AND gate is changing to 0. Whenever one of the input the AND gate is changing to 0, AND gate output will be 0. AND gate output will be 0. It is not going to be 1. It is now 1. Whenever one of the input is changing to 0, AND gate output is changing to the 0. But AND gate output changing to 0 possibly only after 20 nanoseconds. Only after 20 nanoseconds from there, from 10. 10 plus 20, 10 plus 20 means at t equal to 30 nanosecond, AND gate output is changing to 0. So, if you keep attention well, this is the thing what we are looking. So, it is the input which is given and NOT gate output we are able to draw like this. NOT gate ka input before t equal to 0 is 0, the NOT gate output is 1. And at t equal to 0 it is getting 1. This 1 is giving a response as a 0 for this NOT gate after 10 nanoseconds, after 10 nanoseconds. And after changing to 1, this input A is not changing. When it is changing to 1 at t equal to 0, बाद में input A is not changing, so that output of the NOT gate is not changing. Now coming to this AND gate, whenever AND gate both the inputs are 1, then only it is 1. At t, before t equal to 0, एक input 0 है, दूसरा input 1 है, एक input 0 है, दूसरा input 1 है, so that it is 0. At t equal to 0, both the inputs 1 है. Whenever both the inputs are 1, AND gate output is 1. But AND gate output 1 when? Only after 20 nanoseconds. From where? From 0. So 0 plus 20. So 20 nanoseconds के बाद it is 1. It is 1. Right? Now inputs, if you look at t equal to 10 nanosecond, one of the input the AND gate is changing to 0. Whenever one of the input the AND gate is changing to 0, AND gate output will be 0. But AND gate output will be 0 when? AND gate output will be 0 only after 20 nanoseconds, because it is the inherent delay of the AND gate. So that after 20 nanoseconds from there, from 10 plus 20, after 30 nanoseconds it is 0. बाद में we are looking one of the input is always 0 to the AND gate, so that AND gate output is always 0. So this is the output of this AND gate. Now we are recognizing both the inputs of this exclusive OR. One input is A, other input is AND gate output. Now these are this A and these are the inputs now XOR gate. These are the inputs of XOR gate. One is A direct input, other input is AND gate output. These are the inputs to the exclusive OR gate. And XOR gate also not responding immediately. Instantaneously it is not responding. XOR output is available for the given inputs only after 10 nanoseconds. Only after 10 nanoseconds. If you are looking, this is the output waveform of XOR, that is Y. It is to be named as a Y based on the problem statement. Problem statement में ये Y बोला, so Y. So exclusive OR between this input A and output of the AND. We know XOR truth table. We know XOR truth table. Whenever both the inputs are same, XOR result is 0. Whenever both the inputs are not same, XOR result is 1. Whenever both are same, XOR result is 0. Whenever both are not same, XOR result is 1. So having this knowledge, we are working here. Having this knowledge, we are working here. So we are looking before t equal to 0, both the inputs are zeros. When both the inputs are zeros, we are having XOR output is 0. At t equal to 0, one input is 1, other input is 0. At t equal to 0, one input is 1, other input is 0. So because of different values of XOR inputs, XOR का दोनों input same values नहीं है, so that XOR output will be 1. XOR output 1 मिलेगा, but XOR output 1 मिलने के लिए कितना टाइम लगेगा? 10 nanoseconds. So after 10 nanoseconds, we are reading XOR output is getting the value as 1. XOR input, एक input 1, दूसरा input 0 at t equal to 0. Before that दोनों input 0. But t equal to 0 में एक input 1 है, दूसरा input 0 है. So when both the inputs are not same, XOR output is 1. but XOR output 1 मिलने के लिए it needs 10 nanoseconds time. It is having inherent delay of 10 nanoseconds. After 10 nanoseconds it is 1. After 10 nanoseconds it is 1. And it is continuing like this. And if you look to the input, so this one of the input of the AND gate at 20 nanoseconds changing 0 to 1. Whenever it is changing 0 to 1, we are looking at 20 nanoseconds, both the inputs are 1. Whenever both the inputs are 1, XOR output will be 0. Whenever both the inputs are 1, XOR output will be 0. But XOR output will be 0 when the inputs are changing at 20 nanoseconds. So to input मिलने के बाद कितना टाइम लगेगा? 10 nanoseconds. So that 20 plus 10 after 30 nanoseconds it is changing to 0. We are looking here, the XOR gate both the inputs are 1 at t equal to 20. मिलने के बाद XOR is taking 10 nanoseconds time. So 20 plus 10 after 30 nanoseconds it is changing to 0. It is changing to 0. And if you look further, if you trace the inputs further, at 30 nanosecond, one of the input of the XOR gate is 0, other input is 1. At 30 nanosecond, one of the input of XOR is 0, other input is 1. So when both are not same, XOR output will be 1. When both are not same, XOR output will be 1. But XOR to change to 1, it needs 10 nanoseconds. From where? From 30. So 30 plus 10. So after 40 nanoseconds, it is getting 1. बाद में XOR input change नहीं हो रहा, so same 1 will continue. So this is the exclusive OR gate output from the given options from the given options अपन check किए तो which is the matching answer? The matching answer we are having as option B. From the given options, if you check the matching answer we are having as this option B. So answer to this question is option B. So it is one of the important question, little difficult question also. To work out on this question, inherently we need to know the XOR truth table and of course and based on the delay association on each gate, we must be able to draw the waveforms, corresponding waveforms. Whenever we are having delay on any gate with X units, after giving the inputs, the response from the device will be only after X units of time. This is the inherently we need to know. If you know well this, it is possible for us to give the correct answer. Let us move to the next question. Let us try this question now. This question is basically from the combinational circuits. A question may we are having a decoder of size 2 to 4 line, and we are having two multiplexers the size of 2:1, and we are having here exclusive NOR gate. We are having here exclusive NOR gate. And if you read the question well, the given digital circuit is built by using 2 to 4 line decoder, 2:1 multiplexers, and an exclusive NOR gate as shown below. Which of the following input combinations will produce, one of the following input combinations will produce the output F as equal to 0? It is a question. It is also we are having as a MSQ question. It is also MSQ question. So try karo. It is also you are having a question as a MSQ. Try karo. Guess the answers. If you try, it is good. If you try well, the answer will be having as this A and C. If you try well, you must give the answers as A and C for this MSQ question. Answers will be reading as A and C for this MSQ question. To work on this question, you need to know the knowledge of the decoder, you need to know the knowledge of the multiplexer, and of course, you need to know exclusive NOR. So this question is combination of the multiplexer knowledge, decoder knowledge, and of course basic logic gates, exclusive NOR, truth tables, etc. Everything what you need. If you try well, the answers we are having as option A and option C, right? So they are having here, this is a decoder. Decoder is having MSB input is A, LSB input is B. Based on this, you must able to speak now D0 will be A complement, B complement. D1 will be A complement B. D2 will be A, B complement. D3 will be AB. A मालूम होना चाहिए. And coming to this multiplexers, we are having here 2:1 multiplexer. The 2:1 multiplexer output equation आपको मालूम होना चाहिए. 2:1 multiplexer output equation is select input S. So select input S. Whenever S is 0, selection is for I0. Whenever S is 0, S complement, selection is for line 0. So it is I0. Whenever select input is 1, it is uncomplementary form. The selection is for line 1. Selection is for line 1. So multiplexer output equation A मालूम होना चाहिए. Okay. And coming to this exclusive NOR. Exclusive NOR gate, whenever it is having both the inputs are same, output is 1. Both the inputs are same, output is 1 for XNOR. When both the inputs are not same, XOR output is 0. इधर अपना question में what is asking, we want to read XNOR output is to be 0. XNOR output अपने को 0 होना. So that what are the inputs we are looking for this exclusive NOR, whenever both the inputs are not same, then only this exclusive NOR gate output is 0. So having the knowledge of this, we are having possibility to answer to this question. We are having possibility to answer to this question, right? So here, to smart work karna, we must do little smart work. If you are looking here, option A and option B में देखे तो option A में C is 0, D is 1. Option B में देखे तो C is 0, D is 1. This C and D inputs are the multiplexer inputs. C and D are multiplexer inputs, right? So C is the input to the bottom multiplexer. If I name this bottom multiplexer output, if I am naming as Y1, so Y1 is this bottom multiplexer output, and let us name the top multiplexer output, let us name Y2. Y2 is this top multiplexer output. So Y2 is depending upon D, Y1 is depending upon C. ऐसा सोचना, right? And if you come to the option C and option D, if you are looking to the option C and option D and option D में देखे तो we are looking here C is 1, D is 1. We are looking here C is 1, D is 1. So when you are working on this question, you have to try one case with C is 0, D equal to 1. Y1 क्या है, Y2 क्या है देखना. When C is 0, D is 1, Y1 क्या है and Y2 is क्या है. And उससे looking to the AB values, you have to check whether XNOR output is 0 or not. Similarly, for other case, we are looking option C and D, C and 1, C is 1, D is 1. So for C equal to 1, D equal to 1, Y1 क्या है, Y2 क्या है देखना from these multiplexers. And while looking at the AB values, we need to decide what is the exclusive NOR gate output. So इतना concept involve हुआ ये question में. This much of concept is involved in this question, right? So whenever C is 0, option A and option B का देख रहा अपन. Whenever we are having C is 0, if C is 0, whatever the Y1 we are talking, while substituting the value, C is select input, right? Whenever C is 0, this second term is 0, and first term if you come, it is coming to be C complement. It is coming as C complement I0. C complement I0. I0 is connected to what? You check well. I0 is connected to A B complement. I0 is connected to A B complement. Let me write directly. So whenever C is 0, C complement means 1. Just for your convenience I mentioned, but up directly Y1 AB complement बोल सकते. If you want clarity, इतना लिखना पड़ रहा. So whenever C is 0, C complement, and this is your I0. This is your I0. I0 is connected to AB complement. So if you are working fast, your working style supposed to be whenever C equal to 0, you must able to read this directly as A B complement. So to manage time well in the exam hall, wherever C equal to 0, you must able to write like this. Otherwise, if you are taking like this, you will be having clarity, but this clarity and all other thing will be when you are practicing. So whenever C is 0, C complement, that is 1, right? So it is 1, and I0 is multiplexer. Y1 means it is related to the multiplexer, bottom multiplexer. So I0 is AB complement. ये लिखे बोले तो टाइम लगेगा, उसको अवॉइड करना बेटर है. Similarly, when I am having D is 1, we are having it is to be Y2. So from this equation directly you must read. So whenever we are having D is 1, first term will be 0. D1 means S is 1. S complement 0. So we are having effectively, this is I1. It is I1. I1 क्या है इधर? I1 is A complement B. I1 is A complement B. I1 is A complement B. Right? I1 is A complement B. So finally, what you are having? Finally, what you are looking? F is A B complement exclusive NOR with A complement B मिल रहा. So whenever D equal to 1, it is related with the multiplexer 2 output. It is Y2. Y2 we are having whenever D is 1, first term is 0, second term this is I1. I1 is here A complement B. So directly I am putting here. So finally F will be coming as this Y1 exclusive NOR with Y2. Now you substitute AB values and check. If you substitute AB values and check, so for option A, if you check, definitely it is coming to be 0. So A is 1, B is 0. So A is 1, B is 0 is 1. And coming to this, A is 1 means it is 0. It is 0. B is 1. So it is 1 exclusive NOR 0. 1 exclusive NOR 0 is 0. So that A option is coming to be true. And if you substitute B option देखे तो A is 1, A is 1, A is 1, right? B complement is 0, right? Now exclusive NOR, this coming to this A complement is 0, A complement is 0 and B is 1. So what we are looking, 0 exclusive NOR with 0, it is 0, it is 1. So option B is wrong. Or basically you can see here directly with the substitution without, okay. So similar work it is required with option C and option D. If you are coming to the option C and option D, if you are looking to the option C and option D, what you are having, A is 0, B is 1, C is 1, D equal to 1, similarly this. But basically where you need to start the work, we need to start the work with C equal to 1, D equal to 1. C equal to 1, C equal to 1 is giving directly effect on the Y1. देखो Y1 क्या है? Whenever C is 1, the selection is for line 1. Line 1 is connected to AB, directly here लिख सकते. And whenever we are having, it is AB, right? And whenever we are having D is 1, whenever D is 1, we are having selection of line 1. So line 1 is connected to what? Line 1 is connected to A complement B. A complement B. So that Y2 is A complement B. Right? Then we are having F from this exclusive NOR output. Exclusive NOR output we are reading as AB exclusive NOR with A complement B. Now substitute the values and check. If you substitute the option C value, if you substitute option C value, option C में A 0 है, B 1 है. So A 0, B 1 means it is 0. It is 0. Exclusive NOR. Exclusive NOR. Here A complement is 1, B is 1. So A complement is 1, B is 1 means it is 1, which is giving 0. So that option C is correct. And coming to the option D, we are coming to the option D, we are having A is 1, B is 0. Whenever A is 1, B is 0, it is 0. And exclusive NOR, here B is 0, 0, 0 exclusive NOR 0 is 1. So it is wrong. So finally we are having the correct answers for this question is option A and option C. option A and option C. So it is involving the knowledge of the multiplexer operation. It involves the knowledge of this decoder operation, and of course it needs exclusive NOT truth table knowledge. The combination of these three concepts we are having, this is a question, is one of the good question. Okay. Let us move now little simple question. Let us move now little simple question. It is required to realize a full subtractor using a 3 to 8 line decoder with active high outputs and minimum number of 2 input OR gates The number of OR gates required are, it is a numerical question. So full subtractor we need to realize by using a 3 by 8 line decoder. This 3 by 8 line decoder is having active high outputs and they are allowed to use the 2 input OR gates, but condition is we must use minimum number of 2 input OR gates. The condition is we must use minimum number of 2 input OR gates. A condition hai. So what is the answer? What is the answer to this question? A question का आंसर क्या है? What is the answer you are able to read? आप जो आंसर आपको मिला वो आंसर टाइप करके भेजो, मैसेज करो. What is the answer we are having for this question? एक क्वेश्चन का आंसर क्या है? What is the answer to this question? It is not a complex question. ये तो complex question नहीं है. It is not a complex question. On this question, आपको पहला तो you need to know the difference and borrow equations in the compact canonical SOP form. If you know the difference and borrow equations in the compact canonical SOP form, then you are having possibility to answer to this question. The answer is not coming from anybody. So what we are having a difference equation, मिनटम्स क्या है, डिफरेंस इक्वेशन का, बारो इक्वेशन का मिनटम्स क्या है, ये तो याद में होना चाहिए आप लोगों को. One, 2, 4, 7. 1, 2, 4, 7 are the minterms for difference equation. And borrow we are having the minterms as 1, 2, 3 and 7. These are the minterms for borrow. So after knowing this, at least you try for the answer. At least you try the answer. See how we are giving this with the known truth table of full subtractor. A question is on the full subtractor. So with the known truth table of the full subtractor truth table we are giving. So full subtractor truth table, if you are looking, we are having here A, B and B in. So difference and borrow. If you are remembering well the truth table, difference and borrow both zeros. Here difference 1, borrow also 1. Here difference 1, borrow 1. Here difference 0, borrow is 1. Difference 1, borrow 0. Difference 0, borrow 0. Difference 0, borrow 0. Difference 1, borrow 1. So मिनटम्स क्या है? For difference के लिए 1, 2, 4, 7. borrow के लिए 1, 2, 3 and 7. 1, 2, 3 and 7. So ये equations याद में होना चाहिए. मिनटम्स आपको याद में होना चाहिए. Once you know this, you need to know the knowledge. Once you know this, you need to know the knowledge using a decoder how we are implementing any Boolean function. Using decoder how we are implementing any Boolean function in knowledge आपको मालूम होना चाहिए. So for ADC students, of course, it is well known to you. We did couple of questions. So where let us consider this is 3 by 8 line decoder, and this 3 by 8 line decoder is having the inputs this A, B and borrow inputs, A, B and borrow inputs, and outputs if you look, so D0, D1, D2, D3, D4, D5, D6, D7. Right. We are in need to use minimum number of 2 input OR gates. So for reading difference as well as borrow, we must use only minimum number of OR gates. If you look here, we are having this 1, 2 and 7 are common in both these equations. The minterm 1, 2 and 7 are present in both the difference and borrow equations. So based on this observation, we need to work further with this condition. So iska 1, 2 are the inputs, so that here we are having the minterms as 1 and 2. Minterms here we are reading 1 and 2, right? And next, for this 2 input OR gate, one input is this 7, other input is from this 2 input OR gate output. So here we are having the minterms as 1, 2 and 7. Now, for difference, the leftover is 4. To read the output of this 2 input OR gate as a difference output, 1, 2, 7 is one input and other input is this 4. Other input is this 4. So we are having here the minterms as this 1, 2, 4 and 7. And coming to the borrow minterms we are having as 1, 2, 7 and this 3. So to read the output of this 2 input OR gate as B0, one input is this 3. This 3, other is this 1, 2, 7. So we are having here the min terms as 1, 2, 3 and 7. Now question is minimum how many number of 2 input OR gates required? So answer we are having for this question is 4. A question का आंसर है 4. So when you are having it is a question, it will be asked with the weightage the 2 marks. To get the 2 marks, we are not having any much difficult work. You need to know the difference and borrow equations in the compact canonical SOP forms, and based on the condition you have to work for realizing difference and borrow. Further, you need to know the knowledge how we are using decoder to implement any Boolean function. So recent times you are looking the questions in the GATE exam like this, may not be direct question like this interrelated. So this question is covering the knowledge of your full subtractor and decoder, दोनों का. Okay. So recent times we are not having a question from the decoder. This type of questions you can expect now in the coming GATE exam. Let us come to this question. It is little simple question. It is little simple question. It is mentioned a multiplexer circuit is realizing Boolean function f of ABC as shown below. This is a 4 by multiplexer. A multiplexer circuit this function एक function को realize कर रहा. If function is to be so and so, if the function is to be so and so, then what are the inputs of I1 and I3 is the question. Then I1, I3 what we need to give. This is the question we are having. I1 and I3 what we are supposed to give as the inputs is the question. Try this question. A question try करो. Try to respond. क्वेश्चन का आंसर दे वो ऑप्शन से ABCDs. सो ऑप्शन से आप आइडेंटिफाई कर सकते हैं. This multiplexer is to implement this function. So function we are having f of ABC. It is given one of the simplified form, B complement, C complement, or with A complement, C complement, or with ABC. It is given one of the simplified form. Right. When this multiplexer is implementing this function, line 1, line 3 input value is not mentioned in the circuit. Line 0 का input given, line 2 का input given, line 1 and 3 का inputs not mentioned. And one other important thing here is the variable C is connected to the select input S1, variable A is connected to the select input S0. Based on these connections, what must be I1 value, what must be I3 value, ये है question. So to work out for this question आपको क्या knowledge होना, whenever you want to implement any Boolean function, कोई भी Boolean function आप implement करना चाहे तो you must know the compact canonical SOP form of the Boolean function. I mean, you need to know the minterms of the given Boolean function. For this given Boolean function, we are not reading directly the minterms, we are having here the expression in one of the simplified SOP form. So we must try the minterms of this function. After knowing that, whenever C is connected to S1, A is connected to S0, based on these connections, you must develop a table. In the table, C and A are the column headings. C and A will be the column headings and B will be the row heading. So these are the things as a ADC students you learn. So if you try well, what must be the answer? So let me try first the minterms of this. So minterms of this you can try many different ways. I will teach one of the simplest procedure. It is a minterm 7. If you come to this product B complement C complement, basically we are having the function on the variables ABC. Right? And a product we are having B complement C complement, it means B value must be 0, C value must be 0. Then only the product we are having as B complement C complement. A may be any value. A may be value 0 or A may be value as 1. So that from this work we are able to look the minterms corresponding to the product B complement C complement. So BC will be 0, 0, but A may be 0 or 1. Hence, we are looking here, it is a minterm 0, it is a minterm 4. Okay. Similarly, if you look to the other product is A complement C complement. So from this we are looking, A must be 0, C must be 0, but B may be any value. B may be 0, B may be 1, but A and C must be zeros. We are looking here the minterms as 0 and 2. So what is the conclusion? This product is coming in the group of 0, 4, this product is coming in the group of 0, 2. It is one of the simplest way to work. But most of you may be having a practice. Whenever I am looking at a product like this, you may be putting substitution of this and you are expanding. Okay, that way also you can work, but it is the best way. So finally, we are having a conclusion now. The minterms of this function are 0, 2, 4 and 7. Minterms of this function we are having 0, 2, 4 and 7, right? And C variable is connected to select input S1. A variable is connected to the select input S0. On C and A we are having possible values. C and A के ऊपर possible values है 0, 0, 0, 1, 1, 0, 1, 1. These are the possible values on C and A. In terms of the multiplexer terminology के हिसाब से देखें तो this 0, 0 is referring to multiplexer input line 0, this is referring to input line 1, it is referring to input line 2, it is referring to input line 3. And the variable B is a row heading. B may be 0, B may be 1. Whenever B is 0, B complement, whenever B is 1, it is uncomplementary form. Later, at the intersecting point of every column and row heading, we must read its equivalent decimal value. So if you look here, the decimal value ABC, if you read, it will be 1. We have to read the values of ABC variables in order from MSB to LSB. A is 0, B is 0, C is 1, so decimal 1, right? These are the familiar things for ADC students. So like this, at the intersecting point of every column and row heading we are working. This is 0, this is 2. Once it is 2, without any work I can write here 3. Without any work we can write here 3. Because if we move under any column, C and A variables are not changing, the change is only for the B. Wherever B is changing 0 to 1, it is a plus 2. So under any column it is same plus 2. And if you take the question why it is plus 2, very simple, the variable B power is to the power of 1, it is the reason, not anything else. Not any hidden secret, कुछ hidden secret कुछ भी नहीं है. B position weight is to the power of 1, it is the reason we are having here plus 2. So like this, conceptually if you look, not the by heart, the conceptually if at all we are working, it will be 4, it will be 6, it will be 5, it will be 7. Now, we need to highlight the decimal numbers in this table corresponding to the min terms of the function. The min terms of the function are 0, 2, 4, 0 to 4 and 7. So here our requirement is for I1 and I3. I1 is connected to B complement. While looking to this, it is highlighted. Look at the row heading B complement. And if you come to the I3, it is B. So that I1 must be B complement, I3 must be B. So answer must be this. And for a cross check you want, you can see what is for I0. I0 it is to be 1 because 0 and 2 both are the min terms. And if you come to the I2, see it is mistake basically. It is to be 0, they even wrong typing. Right? Okay. So answer to this question is option B. Try this question. A 4-bit right shift register is shifting the data to the right for every clock pulse. The serial input D is derived by using exclusive OR gates as shown below. After 3 clock pulses, the content T, this is content, the content in the shift register is to be 1011 at QA, QB, QC, QD. After 3 clock pulses, the content of the register is to be this 1011 at QA, QB, QC, QD. What will be the initial content? What will be the initial content of the register? It is a question. It is the most expected question this time. It is the most expected question this time. If you are looking to last 4 or 5 years question papers, there were no questions from the registers. So if any question is coming with a weightage of 2 marks, mostly this type of question you can expect. Here I given a question after 3 clock pulses. To simplify the question, they may be asking after 2 clock pulses. So time spending kam hona bole to instead of 3, they may put the question with the 2 clock pulses or maybe 1 clock pulse. But concept is this. It is the most expected thing. To try. Message your answer. Message will answer what will be the initial content of the register. So selectively, very good questions here I am discussing. Most expected questions we are discussing, not routine questions. Most of the times, of course, it results as a true. Even earlier, whenever last year, last before, whenever we given this GTQ, at least 2 questions came from our discussion in the main paper, in the original paper. If you try well, what is the answer to this? So QA, QB, QC, QD. In the question it is mentioned, after 3 clock pulses, it means after 3rd clock pulse. After 3rd clock pulse, the content in the register is to be this 1011. The content in the register is to be 1011. Then what will be the initial content of the register? It is the question. It is the question. And if you look at the D input, we are having a D input as exclusive OR between QA, QC and QD. So this exclusive OR among this QA, QC, QD is the D input, that is serial input to this register. And whenever we are applying the clock, the data is moving based on the description from MSB to LSB. 1 bit right shift chal raha. Right? So after 3 clock pulses, we want here the data is to be 1011. What will be the initial content of the register? What will be the initial content of the register? It is a question we are having. So after 3rd clock pulse, if you want QA to be 1, then before applying the clock signal, D must be 1. Agar D 1 rahe to that is serial input D. After clock pulse, QA is getting 1. And similar way, if you think after 3rd clock pulse QB, we want to read as 0, so that before applying 3rd clock pulse QA agar 0 rahe to clock ke baad QB will be 0. Similarly, अब 3rd clock pulse QC will be 1, means before 3rd clock pulse QB 1 hona, then after clock signal QC will be 1. Similarly, if you look on the QD, after 3rd clock pulse QD 1 hona, so that before 3rd clock pulse agar QC 1 rahe to clock डालने के बाद it is shifting to flip flop D, that is QD is 1. Right? So serial input D is 1. Right? And it is XOR between QA, QC and QD. So QA is 0 and QC is 1. They are already decided. We need to choose this QD such that D must be 1. So for that you need to know the knowledge of exclusive OR. In the case of exclusive OR, whenever odd number of variables are 1, the result of XOR is 1. Whenever odd number of variables are 1, the result of XOR is 1. Whenever even number of variables are 1, the result will be 0. Having this knowledge, we are deciding this QD must be 0. Then only it is odd number of variables are 1, it is 1. So QD is 1. QD is 1. So before third clock pulse, अगर register में we are having 0, 1, 1, 1, then only after third clock pulse we are having the data in the register is to be 1, 0, 1, 1, 1, 0, 1, 1, right? So how we are giving third clock के बाद में QA 1 होना बोले तो third clock के पहले serial input 1 होना, and so on. This is 0 here, this is 1, this is 1, and we are looking here, it is a required input D is 1. इसका XR है QA, QC and QD से. QA, QC already decide हो गया 0, 1, and QD क्या होना, sorry, QD क्या होना, so QD क्या होना, it is 0. I mentioned there, it is 0, so that here it is 0. So we are talking, it is the content of the register after second clock pulse. Second clock के बाद it is the content we are having in the register now. So second clock के बाद QA, if you want to read as to be 0, a second clock देने के पहले D 0 होना, then only QA will be 0. Same thing if you are extending here, इधर 1 रहे तो clock के बाद इधर 1, इधर 1 रहे तो clock के बाद इधर 1, इधर 0 रहे तो clock के बाद it is 0. Right? Now we are looking the required D input is 0. Required D input is 0. And QA is 1. QC is 0. And we need to decide this QD such that it must be 0. So which value will give a 0? Even होना बोले तो it must be 1. Hence it will be 1. Hence it will be 1. अगर QD 1 रहे तो XR between QA, QC, QD, if you look, even number of variables are 1, so serial input is 0, D is 0. So after second clock pulse, the content we will be having. In other way, after first clock pulse, it is the content we need in the register. This is the content in the register. So first clock के बाद में, if you want to have this is to be content in the register, then D must be 1, then only QA will be 1. Same way if you look, QA need to be 1, QB need to be 0, and QC need to be 1. Right? Now, the D input is 1 and QA already decide हो गया, QA is 1, QC decide हो गया, it is 1. Now we need to decide QD so that the serial input D must be 1. So to get the D is to be 1, XR result is to be 1, then this must be 1. Then only odd number of variables are 1, the XR result will be 1. So we need here, this is to be 1. It is to be 1. So before first clock pulse, if we are having 1, 0, 1, 1, then after first clock pulse 1, 1, 0, 1, and so on. After third clock pulse it is 1, 0, 1, 1. 1, 0, 1, 1. So from the options which is matching them, the matching answer from the options, if you look, the matching answer we are having as option C. After 3 clock pulses, the content in the register is to be 1, 0, 1, 1. The initial content in the register is to be 1, 0, 1, 1. So it is a concept based question. We are having proper conceptual knowledge, it is possible for you to answer this type of questions. So you have to prepare well to this level. We are having reasonable time 20 days, थोड़ा refresh करो बराबर concepts को, you can make it well. Let me go a little simple question now. The number of essential prime implicants of the switching function f of ABCD so and so. We are having here a Boolean function which is on 4 variables. Question is now, for this function, how many products are essential prime implicants? How many products will be the essential prime implicants? It is a question. Try karo. You can make it. Answer, you must mention, message the answer. So to answer this question, on this function we must develop the K-map. A function के ऊपर K-map अपन develop करना पड़ेगा. So A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0. If you want, you can go with this notation. A, B, as per your convenient. C, D are column headings. So 0, 0, 0, 1, 1, 1, 1, 0. So if you want, you can use this notation. C, this is D, right. We are having the minterms 0, 4, 9. So with the practice, try to enter the values directly. It is 0. It will be 4. It will be 9. As a practice होना चाहिए. If you are not having a practice, then of course no option to write the cell numbers like this. So having a practice, writing cell numbers को अपन avoid कर सकते. So 0, 4, 9, 10, 11, 12, 13 and 14 एक बार क्रॉस चेक कर लो. 0, 4, 9, 10, 11, 12, 13 and 14. So question is, how many products are essential prime implicants? As a ADC students, you know, आपका notes में रहे थे, the number of essential prime implicants of the given Boolean function are equal to the number of all possible largest size subtubes in which at least one cell without overlapping. Number of all possible largest size subtubes in which at least one cell without overlapping. Having this knowledge, we are trying to look first all possible subtubes. We are looking all possible subtubes. 0 को we can cover with the 4, 4 को we can cover with the 12, 12 को we can cover with the 13, 13 को we can cover with the 9, 9 को we can cover with the 11, 11 को we can cover with the 10, 10 को we can cover with the 14, and 14 को we are having possibility to cover with the 2. Right? So total number of subtubes, if at all we are looking 1, 2, 3, 4, 5, 6, 7, 8. Total number of subtubes are 8. So number of prime implicants are 8. But question is not on the number of prime implicants, number of essential prime implicants. So you see here 1, 2, 3, 4, 5, 6, 7, 8. So number of prime implicants in the same question के ऊपर number of prime implicants रहे तो your answer is 8. but our question is now on the number of essential prime implicants. So number of essential prime implicants will be only one. So number of essential prime implicants of the Boolean function are equal to the number of all possible larger size subcubes in which at least one cell without overlapping. So this is a cell which is not with overlapping. So this yellow color subcube product only essential prime implicant. So answer we are having for this question is 1. So do you think what I said little simple question bola मैं इसलिए तो. The answer to the number of essential prime implicants is 1. Very good. I am looking answers from many of you. I am looking to the answer from many of you. Little simple, of course. Now let us look to this question. It is also related to the Boolean algebra. थोड़ा स्मार्ट वर्क से काम चलाए तो कम टाइम में आंसर दे सकते हैं क्वेश्चन का. थोड़ा स्मार्ट वर्क से काम चलाए तो आंसर विल बी गिविंग विथ लेस टाइम. But the question we are having here 4 variable Boolean functions, so and so min terms. Which of the following expression not equivalent to f, ये है क्वेश्चन. So ABCD options है. So which of the option is not equivalent to the function f, ये है क्वेश्चन. ट्राई करो आंसर. I want to look to the answers from you. If you look here, these are the min terms of the function, right? I am having when the min term is 0. A min term 0 का products लिखे तो what we are looking product में w complement, x complement, y complement, z complement, right? This min term 0 is available here. इधर missing क्या है? w. So x complement, y complement, z complement है. Missing w बोले तो w r with w complement बोल के डाले तो आपको w complement, x complement, y complement, z complement मिलेगा. So 0 is available there. So 0 is present in this expression. Same thing here, same thing here, same thing here. Okay. So ऐसा ऑब्जर्व करके देखो min terms के ऊपर. थोड़ा 0 और 15 लिए तो थोड़ा जनरली इजी रहती है अपने को. अगर min term 15 लिया समझो, min term 15 if you take min term 15 is product wxyz. प्रोडक्ट क्या है? wxyz. Okay. So if you look here, I am having an xz. xz में if I am having xz, आपको we are prepared well, then ऐसा सब्स्टिट्यूशन वर्क मालूम है. इसके पहले और एक क्वेश्चन के ऊपर दूसरा तरीका से भी मैं बताया सेम सेशन में. सो ऐसा एक्सपेंशन कर सकते हैं, नहीं तो टेबल से भी देख सकते हैं. देन वी आर गोइंग टू रीड दिस प्रोडक्ट हियर, गारंटी. द सेम थिंग यू आर गोइंग टू रीड ए प्रोडक्ट हियर, सेम थिंग यू आर गोइंग टू रीड ए प्रोडक्ट हियर. कमिंग टू दिस, ऐसा पॉसिबिलिटी है क्या? कमिंग टू दिस, ऐसा पॉसिबिलिटी है क्या? रीडिंग दिस प्रोडक्ट wxyz रीड करने का पॉसिबिलिटी है क्या? ऑप्शन डी में वी आर नॉट हैविंग पॉसिबिलिटी. We are not having a possibility of reading wxyz. So based on this, you can pick the answer. This must be the right answer. So this option D is not equivalent to the function f. this option D is not equivalent to the function f. और उसके ऊपर भी आप चेक करना चाहे तो एग्जाम हाल में तो नहीं करो, अभी जो शॉर्टकट सिखाया दैट इज एनफ. अगर इसके ऊपर भी चेक करना चाहे तो यू हैव टू सब्स्टिट्यूट दिस wx values as 1 1 1 1 in this equation. So if you are substituting in the option D these equations, they are looking, so x bar, y bar, z bar we are having. So x is 1, x bar is 0, so first term is 0 हो गया. इधर देखो x bar है 0 है, इधर w bar है a भी 0, so पूरा क्या मिल रहा आपको? 0 मिल रहा. So once it is 0 it is not equivalent to f. A combination 15 के लिए function f value क्या होना? Function f value for combination 15 के लिए 1 होना. Why? It is a min term. Combination 15 is a min term, so f must be 1. But a option D में देखे तो the combination 15 we are reading the value as 0, so that option D is not equivalent to f. So whenever you are having any question like this, most probably you need to try with a 0 and 15 if it is 4 variable. If it is 3 variable, 0 and 7 se try karna. And basically this is with an observation they are doing. So for medicine students, you know, in our workbook, medicine workbook mein, we are having 1 or 2 questions of this nature. So the questions what we are looking here, very selective questions we are having, very selective questions. Let us try this question. Consider the equation 76 the base of x is equal to 2y 4 base of 5, where x and y are unknown. The number of possible solutions. x and y के ऊपर कितना possible solutions है, ये है question. So it is the most expected thing. Number systems में it is the most expected thing. I will conclude end of the session. So from this topic most expected this time, end of the session I will conclude. So try answer. If you try well, the answer you must get as what? So for this what you need? What is the knowledge it is required? While looking to this equation with our number system knowledge, you must conclude x must be greater than 7. x must be greater than 7. ये knowledge होना आपको. And y must be less than 5. This knowledge is required. With our number system knowledge, this is a thing. Of course, in the medicine you are learning all this. So having this knowledge, working on this question little easy. So for this 76 base x and for this number, let us try to look its equivalent decimal values. So if you look to the equivalent decimal value, it is 7x plus 6, and coming to the RHS, 5 square into 2 plus 5y plus 4. ये मिलेगा. So as a medicine students, you know, whenever I am having some expression like this, 3 digits with the base of r, इसका r to the power of 2, r to the power of 1, r to the power of 0, these things learn. So we are looking here, this is 7x plus 6, this is 50, 5y plus 4. So effectively what we are reading here is 7x minus 5y is equal to 48, is equal to 48. I'm right? Now what you need, you have to substitute the values using these conditions. Among these two conditions, which is more suitable to work with less time? Which is more suitable to work with less time? Definitely it is more suitable. Taking y less than 5 is more suitable. If you go for x greater than 7, so many values are possible. So theoretically speaking, infinite number of values are possible. But if you come to this y less than 5, you are going either maybe 4 or maybe 3 or maybe 2. Finally it is 1. So 4 possible. So it will take less time. So to work out while substituting the values. So it is basically equation we are referring. Now let us start with y is 4. If I am having y is 4, what we are reading from this? Either y4 right, or what we are going to read here? Y is 4 means 5 4 is 20, right? So we are looking here, this is 7x and 20. If you are moving to the right side, then it is coming to be 68, and x base must be integer. So if you are looking here, x integer is not possible. So x is coming to be 68 by 7. So integer is not possible. Based on this, this option is not there. Then we are coming to look to the y equal to 3. If we are looking to the y equal to 3, we are having here, this is 7x and 3 we are substituting. So 5 into 3, 15. 15 plus 48. 15 plus 48, I think it is 63. If I am wrong, tell me. So that x value will be having 63 by 7, it is a 9. So what we are looking, y is 3 and x is 9, it is possible, and conditions are satisfied. X is greater than 7 and y is less than 5. Okay, then this is one possible solution. We are looking y is 2. Where y is 2, we are having here 7x, y is 2. So we are looking here 5 into 2, 10. So it is 58. Based on this, we are looking x as 58 by 7. It is not resulting to be integer, so it is not possible. It is not possible. And finally, if you are taking y as 1, if you take y as 1, what we are looking here, 7x, it is 1 means 48 plus 5, 53. So x equal to 53 by 7. Again integer is not possible. So it is also not possible. So final conclusion is, how many possible solutions is the question? We are having here a question as how many possible solutions. When we are having question how many possible solutions, our answer on this question is 1. Our answer on this question is 1. So it is the most expected question. This type of questions you can expect this time. So we are having only one possible solution. Okay. Let's come to this question. Which of the following subtraction results F16? Some ABCD options are given. In all these ABCD options, we are having a subtraction operation between two hexadecimal numbers. We are having a subtraction operation between two hexadecimal numbers. And this question is MSQ question. A question है MSQ. A tricky question है. Without much work, we are having possibility to answer to this question. Without much work, we are having possibility to answer to this question. Without much complex thinking, we are having here possibility to speak the answer. So, without any much work, I can speak the answer this. These are the answers. I will talk. Without any work, how we are speaking, I will talk. मैं बताऊंगा आप लोगों को क्या है उसमें हिडन सीक्रेट क्या है मैं बताऊंगा. Anyway, let's start with the A. To start with the A, BC hexadecimal number, of course, minus AB hexadecimal number. You know well, A, B, C, D, E, F values आपको मालूम है. Is it 10, 11, 12, 13, 14 and 15, right? So C minus B, C is 12, B is 11, so it is 1. Once you are getting 1, definitely it is not going to be F16. It is not going to be F16. इसको cut कर सकते. And coming to this option B, if you look to the option B, option B में we are having here one number is BC, other number is CB. Okay. BC minus CB we are having. So C is 12, B is 11. So 12 minus 11, it is 1. So ये देखते ही बोल सकते A B option नहीं हो सकता. Moreover, if you work further work करने की जरूरत नहीं है और further work किए तो भी this is larger value than this, so result will be the negative. Result will be negative, but we want here F16 means a 15 होना, so ये नहीं होते. This is not possible. And coming to this option C, if you are looking to the option C, we are having here ED minus DE. So D minus E, D is 13. E is 14. So 13 minus 14 you can't do. So you need a borrow. It is coming from the place of 16 to the power of 1's place to the 16 to the power of 0's place. So effectively 16 is coming. So 16 plus D. 16 plus D is 29. 16 plus D is 13. So 29 minus E is 14. So we are having it is 15. So this will be F. And once we are taking borrow out from this E minus 1 will be D. So D minus D is 0. So this option C is matching. Option C is matching. But I was mentioning, इतना काम जरूरत नहीं है. Directly we can speak बोला. How I will talk now. This is D. So D ये order में देखे तो we are going A, B, C, D, E and F. So D E ये है ये order one by one. D E इधर है and इसमें क्या है E D है रिवर्स होके है इधर E D है D इधर है इधर रिवर्स है. Definitely in this situation it will be 15 only. Similarly देखो EF this is EF and इसके पहले क्या है EF के पहले FE है रिवर्स होके है FE. So definitely here also it is 16. So let us check. It is a hidden thing. So FE minus EF. E is 14. F is 15. So you need a borrow which is coming with 16. So 16 plus E, 16 plus 14, 30. 30 minus F is 15. So 15 means F. So borrow take out होने के बाद it is E minus E it is 0. So you see it is F. So whenever we are having the numbers like this in this sequence something EF your FE, your DE your ED. Service में रहे तो definitely it is 15 in this hexadecimal number case. And this sort of rule is not only for this hexadecimal number. If you are looking to the octal numbers also it is possible, or nibble numbers or for that matter any number. Suppose I am having a number as 5, 6 hexadecimal, sorry, octal number minus 6, 5. इसका भी देखो, I am having the result as 7. So R is 8 and R minus 1 is 7. Same thing. Here R is 16. Here R is 16. R minus 1 is 15. 15 is F. Same way here also. So you can check here. 65 it is octal number minus 56 it is octal number. So 5 minus 6 you can't do. 5 minus 6 you can't do. We need a borrow. It is coming from the 8 to the power of 1's place. So 8 plus 5. 8 plus 5 is 13. Minus 6 it is giving 7. It is giving 7. And here borrow transfer होने के बाद 5 minus 5 0. It is the one what I said here. So it is observation, it is a hidden thing. So if you are having a knowledge of this small thing, this question you don't look as complex question, you don't spend much time to answer to this question. You don't spend much time to answer to this question. Okay? इसके लिए ज्यादा टाइम जरूरत नहीं है. Okay, so these are the things you need to be familiar before entering to the exam hall. This type of things. Let us come to a little simple question now. 6 complement of the given number. 6 complement of the given number. The given number is 2220 base of 6. इसका 6 complement क्या है? ये है question. message your answer. What must be the answer to this question? So if you look here, it is the given number, the base of 6. It is asked 6 complements. 6 complements. So whenever R is 6, 6 complement is R's complement. 6 complement is R's complement. So to read R's complement of this number, you have to read first. You must read first for this number 5's complement. So 5's complement of this number we are reading while subtracting every digit from 5. While subtracting every digit from 5, we are having here it is 5. This is 3. This is 3. It is 3. Right? Now, to read 6 complement of this number, a 6 complement of this number read karna bole to, we need to add 1 to the rightmost digit. We need to add 1 to the rightmost digit. So while adding 1 to the rightmost digit, if you are reading 6, it is wrong. Why it is wrong? Whenever we are having radix is 6, the discretes possible as only this. Discretes possible only this. So what is the answer they are giving? That answer must be using only these digits. What is the answer will be giving? That answer must be using only those digits. So that the closed eyes we can speak because of 6, because of 6, because of 6. ये answers definitely नहीं होते. Whenever the number is having base as 6, the discretes as only 0 to 5, by chance ऐसा options रहे तो ये तो answers नहीं होना चाहिए. Okay, let us look what is the answer then. So 5 plus 1 6. So this 6 what we are having in the radix 6 form, how we are going to write? It is 1 0. So it is the knowledge of the number system. It is the knowledge of the number system. So 1 0 means a carry is forwarded to the next, a carry will be forwarded to the next significant place. Then here it is 0, it is 0. Then it is 4, it is 3, it is 3, 3 3 4 0. So right answer is this. Answer is option D. So it is very familiar to all the middle students if you practice well. अगर ये सब practice किया, this type of questions we discuss in the class. These are the questions which you can expect, this type of things. Looking to be simple, but possibility to do the mistake is more. Right? Let us look to this question, which is related with the Boolean algebra. Try karo for this question. The minimum number of 2 input NAND gates required to realize the Boolean function f of ABC equal to so and so. How many minimum number of 2 input NAND gates required to realize this function? A function realize करने के लिए minimum how many 2 input NAND gates are required is a question. You message करो answer. If you try well, इसका आंसर क्या मिलेगा आपको? So we are having this function which is a b complement or with b c complement or with a complement XOR with b. With your Boolean algebra exclusive OR and exclusive NOR knowledge, a complement exclusive or b आपको मालूम होना चाहिए. It is a XOR b. It is nothing but a complement b complement or with ab. With the Boolean algebra knowledge, it is there. For maybe students, आपका notes में देख सकते, this information is available with you. A complement, B complement, AB. Now, if you group these two terms, we are having here just it is a B complement. With the Boolean algebra knowledge, you can speak. Among these two terms, B complement is common. So within the parenthesis A or with A complement. So this is one. We are having it is only B complement. We are having only this is B complement. Right? So B complement R with B. C complement. This AB. And if you group these two terms, by using distributivity, it is B complement or C complement. Distributivity property use करके अपन ये try किए तो will be having it is B complement or C complement. So the knowledge of the distributivity property, we are working like this: B complement or with B, B complement or C complement. So this is giving 1, so that B complement or C complement are with AB. Again using the distributive property, we are having here it is nothing but B complement or C complement are with A. So it is the expression we are having. It is the expression we are looking. So for maybe students, whenever we are having a sum term like this, how many minimum number of 2 input NAND gates required? इसके लिए a shortcut formula you learn. It is coming as 3n minus 3. It is coming as 3n minus 3 minus of number of variables which are in complementary form. Here 2 and n is referring to number of literals. Number of literals are 3. So if you are working here well, a formula shortcut formula आपको याद में रहे तो, so 3 into 3 9, 9 minus 3 is 6, 6 minus 2 4. So answer must be 4. Answer must be 4 with the shortcut. अगर ये याद में नहीं है, you are not remembering this, if you are not made a student, you can work even like this: A complement, BC complement, A complement, BC whole complement by using De Morgan's property. So with the knowledge of this De Morgan's property, we are looking now this is BC. Let us consider as A complement, so that here we are reading A complement B, C whole complement. To get A complement, we need 1/9 as an inverter, and and to get BC you need 2 nines. You need 2 nines. So with this also counting we are having same answer. But एक पूरा काम cut करके with the knowledge what you learned in the as a middle students in the class, you can use this formula as 3n minus 3 minus of 2. That minus of 2, the reason is on 2 variables we are having complement. अगर एक ही वेरिएबल के ऊपर कॉम्प्लीमेंट रहे तो माइनस ऑफ 1, कोई भी वेरिएबल के ऊपर कॉम्प्लीमेंट नहीं है देन 0. So finally the answer we are having to this question is 4. The answer to this question is 4. Let us go to this question. It's a good question. Let us work to this question. The square wave C1, it is shown in figure, is given to the clock input of a 4-bit binary up-down counter. It is a good question. It is given to 4-bit binary up-down counter whose up-down inputs fed with the pulse train PU. It is a pulse train PU. The counter is negative edge triggered 1. Counter is negative edge triggered 1. The counter starts from with 0 0 0 0 and it will reach 0 0 0 again at with clock pulse. After how many number of clock pulses, the counter is back to the same initial state 0 0 0 0 is the question. Very good question. Very good question. Answer बताओ. It's a very good question. It's a very good question. Selectively, very selective questions we are having here discussion, and each question whenever you are discussing, if you are prepared well, you may be identifying while looking to 2-3 different concepts, or we are able to revise 2-3 different concepts while working any one of the question. Majority of the questions, may not be every question, but majority of the questions. So selectively I have chosen the questions here in this GTQ. So it is mentioned binary up-down counter. Binary up-down counter it is mentioned. So this knowledge, so hopefully everybody knows. A up counter bole to it is going 0, 1, 2 and so on 15 back to 0. Back to 0. And if you look to the down counter, अगर down counter देखे तो it will be 0, 15, 14 and so on 1 back to 0. It's a down counter, right? Initially counter is with all zeros. So if you are looking here, flip-flop outputs as Q3, Q2, Q1, Q0. So here initially it is mentioned all zeros. The flip-flops what we are using here as per the question statement, they are negative edge triggered flip-flops. So once they are negative edge triggered, whenever clock is falling from 1 to 0, this arrow mark is the reason why it is mentioned here. Whenever clock is falling from 1 to 0, at that time effective change in the flip-flop. Whenever clock is changing 1 to 0, at that time only we will be having effective change in the flip-flop. This up-down counter based on this PU, based on the PU, may be having up sequence or may be having down sequence. Based on this PU input, may be having up sequence or down sequence. based on the description default, what we need to understand, whenever we are having PU is 1, whenever PU is 1, it becomes up sequence. Whenever this PU is 0, default, it is to be understood as a down sequence. अगर PU वैल्यू लॉजिक 1 रहे तो it is up sequence counter. अगर PU वैल्यू 0 रहे तो it becomes down sequence counter. It becomes down sequence counter. While comparing PU with the C1, while comparing the PU C1, if you look, so PU, if you are looking, if you start from here, the next cycle is starting from here. Next cycle will start here. So during this interval, how many clock pulses are entering to the counter? During this interval, 1, 2, 3 clock pulses are entering. During this interval, we are looking here, 3 clock pulses are entering to this up down counter. And one observation we are having here, for the first 2 clock pulses, PU is 1. For the first 2 clock pulses, critical observation, for first 2 clock pulses, we are having PU is 1. But for third clock pulse, we are having PU is 0. Whenever PU is 1, it becomes up sequence counter. Whenever PU is 0, it is a down sequence counter. So during this interval, 3 clock pulses are entering. Out of these 3 clock pulses, for 2 clock pulses, this up down counter is taking, for 2 clock pulses up sequence, for 1 clock pulse it is down sequence. 2 clock pulses के लिए up sequence, बाद में for third clock pulse it is taking down. Effectively what we are looking, effectively it is up sequence counter. For 3 clock pulses, increment is only 1. It is effectively up sequence counter. For 3 clock pulses, effective increment is only 1. For this total duration, for 2 clock pulses, increment by 2. For third clock pulse, decrement by 1. 2 minus 1, 1. So effectively increment is only 1. So for our understanding, you can consider it is up sequence. This up sequence increment is by 1 for 3 clock pulses. The subsequence increment is 1 for every 3 clock pulses. It is the inner logic you need to understand. It is the inner concept you must understand. It is the inherent concept you must understand. Right? If you want more clarity, I will talk. For clock, first clock pulse when it is starting, it is incremented. फर्स्ट क्लॉक पल्स इधर मिल रहा, PU1 है, आपको सीक्वेंस, so 1. सेकंड क्लॉक पल्स it is 1 only, so increment. But when it is coming to the third clock pulse, PU is 0, so it is decremented, because whenever PU is 0, it is a down counter. Whenever PU is 0, it is a down counter, so that it is decrementing by 1. Once it is decrementing 1 means it is coming to be 0, 0, 0, 1. So if you are taking a bunch of these 3 clock pulses, effectively change is only 0 to 1. So bunch of 3 clock pulses, if you take, for every 3 clock pulses, increment is only 1. It is a thing we need to observe. Once you are observing this, question becomes easy. Right? So based on this, you have to look now. When we are reaching to, when the counter is required to reach, to this 14, counter decimal value to reach to this 14, how many clock pulses required? Let us try to identify. To reach to this decimal 1, how many clock pulses? 3 clock pulses. And similar way, if you think from this To reach to decimal 2, you are in need of 3 more clock pulses. You need 3 more clock pulses. If you want, I will put the details also. So either one ho gaya. Then with the 4th clock pulse, we are looking here, it is 0, 0, 1, 0. The 5th clock pulse 0, 0, 1, 1. With the 4th clock pulse, this is 4th. It is 1, 2, 3, it is 4, it is 5, it is 6. So 4, 5 के लिए increment हो रहा, 6 में क्या हो रहा? Decrement because PU is 0. So 0, 0, 1, 0. So what we are looking, it is reached now from this 0 to 2. So increment is how much? Increment is only 2. Increment is only 2. This increment is 2 for how many clock pulses? Here 3. Either be 3. So after 6 clock pulses. From the beginning, if you look, after 6 clock pulses, we are having increment by 2. So for every 3 clock pulses, we are having increment. For every 3 clock pulses, we are having increment by 1. So based on this knowledge, I am asking you to reach to the state of this 14, decimal 14. How many clock pulses required is the question. So when we are having how many clock pulses required, it is coming to be 42. So after 42th clock pulse, after 42nd clock pulse, after 42nd clock pulse, we are having it is decimal 14. For every 3 clock pulses, increment by 1. With the 6 clock pulses, increment by 2. With the 9 clock pulses, increment by 3, and so on. To reach to this decimal 14 in this counter, we need 42 clock pulses. For every 3 clock pulse, increment by 1. To reach to 14, 14 into 3, 42 clock pulses. 42 clock pulses. Now, here interesting story. We are having Q3 I said, no? Q3, Q2, Q1, Q0. After 42nd clock pulse, we are having the value as 1110. So after 42nd clock pulse, we are having this. Okay. Then 43 and 44, we are having increment by 11. Right. So with the 43 clock pulse, what we are going to look? It is 1. It is 1111. It is up sequence counter. It is up sequence counter. After 15, what it is reaching? It is reaching to 0. After 15, it is reaching to 0. So cycle will restart. After 15, it back to 0. So that after 44th clock pulse, it is coming to 0, 0, 0. Hence, answer we are having to this question is option C. Answer is option C. It's a very good question. Very good question. It's a concept-based question. So, while looking at this, we are understanding for every 3 clock pulses, increment by 1. Right? For every 3 clock pulses, increment by 1. Based on this, to get 14, we need 42 clock pulses. 43 में 15 बन गया. 44 में cycle will restart. It is starting with 0. ये समझना. Right? So, it's a very, very good question. Let us come to a little simple question now. Let us come to this simple question now. A 4-bit down counter, it is a down counter, is used to control the output of the multiplexer as shown in figure. The counter is initially, this is a counter, initially all the bits are 1, A3, A2, A1, A0, all the bits are 1. Then the output of the multiplexer will follow the sequence. Output of the multiplexer will follow the sequence, a question. And we are looking, A1 is the enable input to this multiplexer. A3, A2, A0 are the select inputs. So to work out on this question, you need this counter knowledge, you need this multiplexer knowledge. Multiplexer knowledge में enable point भी बहुत important इधर. Enable point भी important. A multiplexer will be active if and only this enable is 1. Multiplexer will be active if and only enable is 1. So we are having here active high enable. A knowledge होना चाहिए आपको. Multiplexer is having active high enable. A knowledge होना चाहिए. With the knowledge of this, we can speak now the answer. Active enable. This knowledge is required. So with all this knowledge, if you try well, what is the answer to this question? A question का answer क्या है? What is the answer to this question? So let me look like this. A3, A2, A1, A0. Initially we are having this value. It is mentioned. And based on the connections, A1 is enable, this is enable, both important, this point, this particular thing, it is connected to enable. Whenever enable is 1, multiplexer is active. And A3 we are having as select input, S2, A2 is select input, S1, A0 is select input, A0 is select input S0. A0 is select input S0. And output Y, we have to look based on this. So while applying the clock, if you look, what a sequence we are having is a question. So initially enable is 1. Whenever enable is 1, multiplexer is active. Multiplexer is active and A3, A2, A1 we are having as 1, 1, 1. Whenever A3, A2, A1 are 1, 1, 1, that is select inputs all are 1. The selection will be from this multiplexer for line 7. So we are having this Y is I7. So initially it is I7. So while looking to this I7 from the options, कोई भी option को नहीं ही हटा सकते. But to proceed further, if you apply the clock, it is a down counter. Counter is down counter. So once it is a down counter, it is decrementing by 1. It is decrementing by 1. Even for this, enable is 1. Enable is 1 means multiplexer is active. A3, A2, A0, if you look 110, it is 110. 110 means selection is for line 6. So we are having here, it is I6. It is I6. So once it is I6, we are having, if our work is right, option A को option B को हटा सकते because I7 के बाद इधर 0 है, इधर भी 0 है, so हटा सकते. So C and D में कुछ भी possibility है. When we are going to the next clock pulse, it is decremented by 1. So 15 से 14 आया, now it is going to 13. It is going to 13. At this time, enable we are having 0. Multiplexer enable 0 रहे तो output will be 0. Output will be 0. Option C में we are looking as this 5, whereas here it is given as 0. Based on this, definitely this is also not possible answer if at all our work is everything right. So most probably our answer must be this. So let us check further. अगर एग्जाम हॉल में टाइम नहीं है, इतना करने के बाद you must choose answer as option D. You must choose the answer as option D. Okay. When we are applying third clock pulse, it is decremented by one more. So in this case also enable is 0, it is 0, it is working. With the next clock pulse, it is coming decrementing by 1. It is now 12 to, it is reaching to 11. It is reaching to 11. At this time, enable is 1. Once enable is 1, multiplexer is add to, select inputs we are having 1, 0, 1. Once selected input is 1, 0, 1, 1, 0, 1. From this multiplexer we are having selection for I5. Selection is for I5. 1, 0, 1 means 1, 0, 1. So selection is for I5. Right? This is coming to be true. With the fifth clock pulse, we are looking decrement by 1. So enable is 1. We are having multiplexer active. So 1, 0, 0, 1, 0, 0 है तो from the multiplexer selection is for I4. 1, 0, 0 from the multiplexer I4. With attention calm, you must work. इतना detail में लिखने की जरूरत नहीं है. And the sixth clock pulse, if you look, it will be 1, 0, 0. It is decremented by one more. So 9 to, it is 10, 10 to 9. Enable is 0, so 0. It is matching. And with the seventh clock pulse, it is decrementing by one more, so 0. So if you are looking here, it is matching. So answer to this question is option D. Option D. If time permit, you are going for full length. Otherwise, as and when after second clock pulse, you are having it is I5, immediately cut करने के बाद you are going for the answer option D. Okay? Simple question it is. It needs the knowledge of the multiplexer. It needs the knowledge of the down counter. The help of with the knowledge of both these things, we'll be having answer to this question. Let us look to this question. In the given counter circuit, initially all the flip-flops are cleared. After 3 clock pulses, the content in the counter at Q2, Q1, Q0. ये है question. Try करो. So with the proper attention, you must work. Then you will be giving correct answer for it. For majority of the question, it needs your attention, your concentration. So if you try well, what must be the answer? What must be your answer? It is flip-flop 2, flip-flop 1, flip-flop 0. While looking to this, you need to have an observation. External clock is coming to flip-flop 0 and flip-flop 1 directly. But external clock is not coming to flip-flop 2. Flip-flop 2 के लिए external clock directly नहीं मिल रहा. Flip-flop 2 के लिए clock is coming from the flip-flop 1 output. Based on the symbolic representations, we are identifying flip-flops are negative edge triggered, so that this flip-flop 2 will change whenever Q1 is changing 1 to 0. Negative edge triggered whenever Q1 is changing 1 to 0, it is getting effectively clock. J and K connected to 1. So J and K may be connected to 1. But unless Q1 is not changing 1 to 0, it is not going to toggle. Whenever the Q1 is changing 1 to 0, it will toggle. It is coming complement to the previous state. So this observation is required. So it is recent time, no questions from the counters. This type of questions are important. This type of preparation is important. So you can expect this type of question. So we are looking here this Q2, Q1, Q0. Initially all are cleared. So we are looking here initial value as 0, 0, 0. All the flip-flops are cleared means all are with the values of zeros. We are looking Q2 is a special case. Whenever Q1 is changing 1 to 0, this Q2 has to change. But other two flip-flops, it is not the case. It is not the case, right? So if you look to the J and K values, J and K values of the flip-flop 2, we are having 1, right? And for other two flip-flops, if you look, flip-flop 1, J is Q0, J is Q0 and K is 1. J is Q0, K is 1. If you look to the flip-flop 0, flip-flop 0, J is Q2 complement, J is Q2 complement and K is 1, K is 1. Based on the connections, we are having this. So our question is limited to 3 clock pulses. 3 clock pulses होने के बाद what is the value of the counter is the question. So based on the given connections we are having, this is the information. Flip-flop 1 का inputs है Q0, J, K is 1. Flip-flop 0, J is Q2 complement, J is Q2 complement and K is 1. These two flip-flops will change based on the inputs. Based on the inputs, these are changing with respect to clock. But flip-flop 2 is concerned, it will change if and only. It will change if and only this Q1 is changing. This Q1 is changing. Whenever Q1 is changing 1 to 0, at that time only it will change. It will toggle. Whenever Q1 is changing 1 to 0, at the time only it will toggle, because the flip-flops are having negative edge triggered clock. Now before applying any clock signal, if you look the inputs, Q0 is 0, Q2 complement is 1. Now if clock is applied to the circuit, अगर clock circuit को apply किए तो flip flop 1 0 1 input, so that same 0, truth table on the JK flip flop. Flip flop 0 1 1, flip flop 0 1 1 means toggling, it is changing 0 to 1. Coming to the flip flop 2, flip flop 1 change होने के बाद flip flop 2 देखेंगे, क्योंकि if the Q1 is changing 1 to 0, then only it is changing. So flip flop 1 is changing 0 to 0, so no clock effect to the flip flop 2, so no change here, right? Now based on this present state, initially all clear होगा. Now first clock के बाद ये आया. Based on this present state inputs देखिए तो Q0 is 1, Q2 complement is 1. If you apply the clock, because of this 1 1, they are not looking flip flop 2. Q1 देखने के बाद देखेंगे 1 1, it is changing 0 to 1. Toggle 1 1, it is changing. It is toggling, flip flop 0 also toggling. Q1 is changing 0 to 1. Q1 is changing 0 to 1, not 1 to 0, so that it is not the clock to the flip flop 2. So no change. Now based on this present state inputs, Q0 is this, right? Q2 complement is 1, Q2 is 0, so Q2 complement is 1. Now if you apply the third clock pulse 1 0, if you apply the third clock pulse, because 0 1 flip flop 1 is changing 1 to 0, flip flop 1 is changing 1 to 0, flip flop 1 is changing 1 to 0, repeatedly I am mentioning, it is having importance. This 1 1 is giving toggle. So flip flop 1 is changing 1 to 0, then it is a clock to the flip flop 2, then it is a clock to the flip flop 2. So flip flop 2 is changing to 1. When 1 to 0, to highlight, I took here this arrow mark, it is a toggle to the flip flop 2, so it is changing 1 to 1, it is changing 0 to 1. Question is limited to only 3 clock pulses. Based on this, we are having answer to this question is option C. Answer is option C. So, very good question. With attention you need to work, not with any simple तरीका से काम नहीं होते. Concentration से, concept से काम किए तो you will be having the correct answer to this question. Right? In continuity to the previous question, in the above counter circuit, previous question only, counter circuit, if each flip-flop is having propagation delay of 5 nanoseconds, if each flip-flop is having a propagation delay of 5 nanoseconds, then which is our frequency of a clock will operate the counter satisfactorily. In the previous counter circuit, अगर each flip-flop का propagation delay 5 nanoseconds रहे तो which is or of the frequencies among the ABCDs will operate the counter circuit satisfactorily? It is a question. So each flip-flop is having a propagation delay of 5 nanoseconds. इसका delay 5 nanoseconds. इसका delay 5 nanoseconds. इसका delay 5 nanoseconds. Right. These two flip-flops are changing simultaneously. Flip-flop 0 and flip-flop 1 with the external clock pulse, they are changing simultaneously. But this flip-flop will change after changing the flip-flop 1 from 1 to 0. So तब तक flip-flop 1 change नहीं होते, 1 to 0 तब तक ये तो change नहीं होते. ये change होने के बाद it will start to change. It will start to change. So, if you look, if I am applying this clock here, it is nth clock pulse, suppose it is a clock, it is the nth clock pulse. Then we are having nth clock pulse, when we are having nth clock pulse, what we are looking, these two are changing simultaneously. To change this, 5 nanoseconds time is required. A change होने के बाद, it is to start to change. So that to apply the next clock pulse, we need to wait. To apply the next clock pulse, we need to wait until it is going to change. Until it is going to change. It means a change होने के लिए 5 nanoseconds, a change होने के बाद a change होने के लिए 5 nanoseconds. So until to this time, we are not having possibility to apply the clock. Both the flip flop, this flip flop and these two flip flops, पूरा change होने के बाद ही clock apply करना. So minimum time period कितना होना अपने को between the two succeeding clock pulses. Minimum time कितना होना between two succeeding clock pulses? 10 nanoseconds. Between two succeeding clock pulses, we need minimum 10 nanoseconds. Minimum 10 nanoseconds होना, बाद में you can apply. अगर 15 nanoseconds good, 20 nanoseconds good, but if you are applying if the time gap between the two succeeding clock pulses, say 8 nanoseconds, then it is not going to change. We are going to have the wrong results. We are not having proper operation. We are having 6 nanoseconds. It is not getting chance to change. So we are not looking to the proper operation. Proper operation होना पड़े तो between two succeeding clock pulses minimum 10 nanoseconds time होना. 10 nanoseconds के बाद में minimum 10 nanoseconds. उसके टाइम गैप 10 nanoseconds के ज्यादा रहे तो चलेगा, कम नहीं होना. So based on this, what is the maximum clock frequency we can use? Based on this, what is the maximum clock frequency possible for us to use? Maximum clock frequency possible for us to use based on this as is 10 nanoseconds. So that 1000 divided by 10 into 10 to the power of 6 लिए तो 100 megahertz. We can use maximum 100 megahertz clock frequency. We can use maximum 100 megahertz clock frequency. उसके ऊपर नहीं जा सकते. उसके अंदर यूज कर सकते पर उसके ऊपर नहीं जा सकते. So based on this, from the given options, you have to choose the answer. So 100 के अंदर होना, 100 के ऊपर नहीं होना. So 100 के अंदर क्या क्या है, 100 के अंदर ये है, 100 के अंदर ये है. It is also a MSQ question. So that answer we are having as B and D. Right? Answer is B and D. Suppose आपका frequency 50 megahertz, then इसके हिसाब से टाइम पीरियड कितना होते? 20 नैनोसेकंड्स. चेक करो बराबर 20 नैनोसेकंड्स. मिनिमम कितना होना अपने को? मिनिमम 10 होना. उसके ऊपर है तो चलेगा. बिटवीन टू सक्सीडिंग क्लॉक पल्सेस मिनिमम 10 होना. उसके ऊपर है तो चलेगा. वी आर हैविंग से 50 मेगाहर्ट्ज. टाइम गैप बिटवीन टू सक्सीडिंग क्लॉक पल्सेस कितना है? टाइम पीरियड 20 नैनो. इट्स ओके. बट इफ यू टेक 150, उसके हिसाब से कैलकुलेट किए तो we'll be having a time less than 10 nanoseconds. Once we are having less than 10 nanoseconds, then flip-flops won't operate satisfactorily. Having this knowledge, we are having a conclusion on this question. To operate satisfactorily, the possible frequencies which are possible to use, option B and D from the given options, less than or equal to 100 megahertz, maximum 100 megahertz. So option B and option D are the answers. Let's look to this question from the Boolean algebra. The simplified form of the Boolean expression, the simplified form of the Boolean expression. So if you try well, आप without much time आप आंसर दे सकते. It is option B. It is option B. So if you look here, we are having possibility to expand this by using De Morgan's property, A complement or D complement, right? So बाकी terms I am not touching. बाकी terms I am not touching. Now, with the practice, good practice of your Boolean algebra, आपका अच्छा practice Boolean algebra क्या है? D complement, इसको group करो. When you are grouping this AD with a D complement, AD with a D complement, when you are grouping using De Morgan's using distributivity, you will be having it is A or D complement. एक practice होना आपको, एक practice होना A or D complement and with D or D complement. For many students, such question, many questions we discuss in the class and आपका वर्कबुक में मिलेगा, CPQ में भी मिलेगा A or D complement, A or D complement. So while grouping these two, we are having A or D complement. So देखो इधर this terms group करने के बाद we are looking here A or D complement and इधर देखिए तो A बार है, इधर एक I touch only this, इधर A बार है. So while grouping this it is 1. So 1 or with anything will be 1. So answer is B. इतना कम टाइम में आंसर करना, शॉर्टकट में आंसर करना, स्टेप बाय स्टेप कोई भी नहीं देखते. इसको एक्सपैंड करो बोला मैं, एक्सपेंशन करने के बाद ऐसा मिला. ए डी बार को इधर से ग्रुप किया, डी बार को इधर से ग्रुप करने के बाद वी आर लुकिंग हियर इट इज ए और डी बार मिला. सो ए बार इधर ऑलरेडी है, इधर भी है. सो ए आर विथ ए बार इट इज 1. बाकी टर्म्स कुछ भी होने दो, आंसर इज 1. बाकी टर्म्स कुछ भी होने दो, आंसर इज 1. राइट? The given Boolean equations are on Boolean variables A, B, C and D. These are the equations. The number of Boolean variables will be having the value as 1. The number of Boolean variables will be having the value as 1 to satisfy the above simultaneous Boolean equations. Among these 4 Boolean variables, how many number of variables are having the value as 1 is the question. Among these ABCD variables, how many variables are having the value as 1 is the question. It is a question. Good question. Recent time there was no question of this nature. It is important. This type of things you can expect. I am having one of the equation as this A complement B R into C equal to 0. So to get the C, to get this equation is to be 0, guarantee C must be 0. Guarantee C must be 0. ये तो conclusion हो गया. ये दोनों टर्म्स 0 होना, इधर A complement B इधर तो डिसाइड नहीं कर सकते, मगर इधर तो डिसाइड कर सकते. C must be 0. C must be 0. C is 0. C is 0 means इधर I am having 0. It is 0. Means this term is 0. We want AB equal to 1. We want AB equal to 1 based on this. So it is 0. It is equal to 1 होना पड़े तो A must be 1, B must be 1. Then only it is 1. A must be 1, B must be 1. Then only it is 1. थोड़ा शॉर्टकट स्मार्ट वर्क से काम चलना. ए इक्वेशन से C0 बोला, ए C को सब्स्टिट्यूट किए तो ये टर्म 0 बन गया, पर इक्वेशन 1 वैल्यू है. 1 is possible if and only A and B both are 1. 1 is possible if and only both are 1. So we decided till now ABC values, A is 1, B is 1, C is 0. Now you substitute these values here. C 0 है, C 0 है बोले तो it is 1, A 1 है, B 1 है, D unknown, D कितना होना फिर? D 1 होना. So how many number of variables are with the value of 1? 3 variables we are looking at the value of 1. So answer to this question is 3. Answer to this question is 3. Answer to this question is 3. Let us try this counter circuit. A counter circuit is designed on the following switching sequence. So counter is switching in the sequence 0, 2, 4, 3, 6 using JK flip-flop, T flip-flop and D flip-flop as shown below. The inputs of the JK flip-flops are X and Y respectively. The X and Y inputs are a question. So this counter is basically designed to switch on this switching sequence, right? And here देखे तो D क्या कनेक्शन है मालूम है, T का कनेक्शन भी मालूम है, मगर A फ्लिप फ्लॉप, दिस इज JK फ्लिप फ्लॉप, JK फ्लिप फ्लॉप का इनपुट्स नहीं दिया इधर. So JK इनपुट क्या बोल रहा है? X and Y. What must be X and Y is the question. So question is related with the synchronous counter design. Clock is common to all the flip-flops. Once the clock is common to all the flip-flops, the question is related with the synchronous counter. So only one flip-flop के लिए काम करना, बाकी 2 flip-flops के लिए आप काम करने का जरूरत नहीं है. But it will check the student knowledge on the synchronous counter design. It will check the student knowledge on the counter design. So for that purpose, we need to work like this: Q2, Q1, Q0. Zero, zero, zero. With the first clock pulse, it must get 0, 1, 0. The second clock pulse, it must get 1, 0, 0. The third clock pulse, it must get 0, 1, 1. With the fourth clock pulse, it must get 1, 1, 0. The fifth clock pulse, it must go to 0. So it is a modified synchronous counter basically. 0, 2, 4, 3, 6, back to 0. So flip-flop 2 का inputs we are interested. J and K. With the knowledge of excitation table, we need to work. Excitation table मालूम होना. With the knowledge of the JK flip-flop excitation table, we are working. 0 to 0, 0 don't care. 0 to 1, 1 don't care. 1 to 0, don't care 1. 0 to 1, 1 don't care. 1 to 0, don't care 1. So these are the required excitations to switch like this. And now we are looking the compact canonical equations for J and K as a function of the present state of the flip-flops. So for that, we have to look equivalent decimal values. It is 0, it is 2, it is 4, it is 3, it is 6. And we know in this counter, few of the states are not used with circuits. Suppose if you look here, state 1 is not present. State 1 is not present means it is not used with circuit. We are having the usage in 3 flip-flops, only 5 states are used. So 3 states are not used. State 1 is not present here. State 5 is not present. State 7 also not present. So they becomes common don't cares while writing these flip-flop inputs. This J, if you look, it is having the minterm, this 2 and 3, minterm 2 and 3. So minterm is not 1, minterm is 2, equivalent decimal value. So minterm 2 and 3. And don't cares if you look, don't cares if you look, don't cares we are having here from the driving input 4, 6, from the driving input 4, 6, from unused states 1, 5, 7. So 1, 4, 5, 6, 7. 1, 4, 5, 6, 7. So 1, 4, 5, 6 and 7. Right? And if you come to the K के लिए कुछ ज़्यादा काम करने का जरूरत नहीं पड़ेगा. K, these are the 2 minterms 4 and 6 are the minterms. Remaining all are don't cares. 4 and 6 are the minterms. Remaining all are don't cares. So 0, 1, 2, 3, 5 and 7. So default K का तो 1 बोल सकते. K का 1 बोले तो Y is 1. Y is 1 बोले तो from the given options क्या A ऑप्शन नहीं हो सकता. A ऑप्शन नहीं हो सकता. Y 1 होना, ये दोनों ऑप्शन में एक ऑप्शन सही होना चाहिए. From these 2 options, 1 option. So ऐसा कुछ स्मार्ट वर्क भी चलाना. So to identify among these 2 which is right, you have to read the equation for J in the minimal form. So for that purpose, you need to use the K-map. K-map का जरूरत पड़ेगा. So Q2, Q1, Q0. So minterms we are having as 4 and 6. This is 4. Sorry, 2 and 3. Sorry, very sorry. 2 and 3. 2, 3. Minterms don't case. We are having 1, 4, 5, 6, 7. So from this, if you read, this is the largest size of Q. So J, if you are working, it is Q1. So this is mentioned as X. So which is matching? Option D is matching. J is Q1, Y is 1. So right answer to this question is option D. So answer to this question is option D. So you can have a question related with the counter design, but the question may not be asked on all the flip-flops. Question may be limited to one of the flip-flop. So once you are giving the right answer for this flip-flop, even if it is required for T or D, you can work. So this question is basically checking the student knowledge, how student is having the knowledge in the synchronous counter design. Right? Let's look this as a last question now. The number of literals in the minimal POS expression of the Boolean function. We are having in need of POS expression, and here minterms are given. Minterms are given, and of course these are the don't cares. So we have to use the K-map for this purpose. The function, we are looking to the variables as A, B, C, D. The variables are A, B, C, D. So 0, 0, 0, 1, 1, 1, 1, 0. Right. So don't cares are 3 and 9. Don't cares we are having this 3 and 9. For your clarity, if you want, you have to write the cell numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3 and 9. And these are the minterms. But we are interested to write the POS form. POS के लिए we need max terms. We are in need of max terms. So all leftover terms we are having as the max terms. So leftover देखे तो 0 is not here. So it's the max term. 1 not here, max term. 2 not here, max term. 3 don't care. Okay. 4 is not here, it is the max term. 5 is min term, 6 is a min term, 7 is a min term. Okay, 8 is a max term. Okay, 9 of course don't care. 10, 11, 12 is the max term. 13, 14, 15 are min terms. So, how many number of literals in the minimal POS form is a question? It is a question. We are having here the possibility of grouping these 4 cells. So while grouping these 4 cells, it is C or D, some term. We are having possibility to group these 4 cells, it is having A or B. So when you are rating the function f of ABCD, this function f of ABCD, then we are looking, this is the expression, this is the POS expression. It is a POS expression. So, how many number of letters we are having in the minimal POS expression is the question. So, answer we are looking to this question is 4. If you count, answer is 4. Right? So, questions, I am stopping here. I want to give few conclusions. Most expected question this time will be from the register. Register से बहुत दिन से क्वेश्चन नहीं आया, so register की क्वेश्चन हो सकता है this time. And we'll be having guarantee question from the number system, guarantee question from the number system, guarantee question from the Boolean algebra. Boolean algebra sometimes may be simple, sometimes may be prime implicant, sometimes may be something like this number of literals. And you can have a question here this time from the combination circuit, integrating 2-3 different topics, integrating, suppose one of the question we did, full subtractor integrating with the decoder. So integrating 2-3 different topics you can expect. So mostly decoder से एक question मिलेगा this time. These are based on, see, looking to last 4-5 years question papers. Just these are my assumptions, these are my conclusions. Mostly you can expect. So what are the questions we covered here? Very selective questions I covered. So what are the questions we discussed? Within this frame line, if you prepare well, within the available time, if you revise well, within these 20 days with the available time, if you revise the wells within this framework, you will be having guarantee each and every question of the digital logic you will be giving correct answer. So let me stop here. Wish you good luck. All the very best. Wish you good luck. All the very best. Be in touch. Bye. Good night.